I'll just kind of follow up on a few different topics here. I'd like to focus a little bit more on phosphorus, and depending on how much time we have, touch a little bit on pH and sulfur as well. But yeah, we'll try to stay on time. And I think, Greg, the schedule you have, you want to finish by 7:30 for supper. So we'll keep that in mind. The other thing too is, Craig, since I'm not there, obviously getting the interaction and discussion, I'll try to pause every so often and make sure there are some questions and give opportunities for that as well. Okay.
Yeah, I unplugged my Yeti mic, so I didn't know if that caused any issues on your end. But if I need to ask you a question, I can always pass along.
Yes. And like I say, I'll just stop every so often and make sure there's no questions there. And yeah, no issues here. Hopefully it's the volume and everything okay for you. Okay, so just a few things, kind of a key points to touch this evening. Like I said, focus a little bit more on phosphorus. We've done quite a few in the last 2-3 years on corn, soybean, and wheat, and really focus on crop response and soil test methods. So like I say, the idea here is really to make those changes and whatever adjustment we need on recommendations on the next round. Like I say, it could be as soon as next year, really, for the case of winter wheat, and we'll see how we are with time for to touch a little bit on sulfur and pH as well. But if not, then we can talk about any questions you have, even if we don't get there. Okay, so and I think I usually like to show this just to put a little bit in perspective what happens to the different nutrients, in terms of whether it's going to the grain or basically go back to the residue, how much of that may be cycling back in the soil. And I think that's very important if you're thinking about how you manage some of these nutrients long term. Okay. And obviously focus here on phosphorus a little bit more. Obviously a lot of the phosphorus tends to go into the grain, right? Most of it goes in the grain. Very, very small fraction basically stay in the residue. And so obviously, if we have good yields over time, we're basically going to be mining that phosphorus. That's basically the key there. And then the other thing too is that, sometimes I get this question, what about, if you're thinking about, using the residue maybe for forage or something, what's the value in terms of nutrient there? And when it comes to phosphorus, there's not a lot, okay? That's a key point there, right? We not really have much left in terms of phosphorus in the residue. Most of that really goes into the grain. Basically the opposite if you're looking at something like potassium, and for this part of the state, potassium typically not a big issue, and probably not going to be in for many years, because especially with grain production, a lot of the potassium tends to kind of stay back there. Very little goes into the grain, and a lot of it cycle back in the soil, right? And so just to keep that in perspective, and like Lucas mentioned in the publication, we also have some of these values. We have for other crops. Always good to kind of keep that in mind, especially as we're thinking about strategy for multiple years of fertility management. If we're putting phosphorus for a couple of years, for example, what can we expect there? And I'll show you some data. Okay, so I'd like to mostly share with you some data, recent data on what we've been doing for phosphorus trials. This is one that this including last year data. We have 30 locations. It's really quite across the state. And so it's still ongoing. We still have data analyzing and samples and so on. And we'll see if we add more site this year. But if not, I think we are getting to the point that I think we have a pretty decent data set here. Obviously, trying to capture different, pH in particular is one of the things that we really want to emphasize, and have a variety of pH there and capture that. As you know, that a key factor for phosphorus that can affect phosphorus, and we do have different tillage systems as well across the state. And so what do we see there? And this average across those 30 locations for corn, and We do have some irrigated. Last year, actually, I think we have mostly irrigated last year. And then we have dryland. I don't know what's the split there, but it's a combination of both. And where do we get the kind of the max response? Somewhere in that about 90 pounds or so. Certainly a little bit above 60 pounds of P2O5. We basically maximize that yield response in the sites that are going to be responsive to phosphorus. And this average across those locations, we are right at 200 bushel. And if you think about it, that 200 bushel corn is going to be removing a little bit more than 60 pounds of P2O5. So this kind of makes sense, right? It's definitely the 60 pounds is a little bit on the low side, but if we're putting something like 90 or more, we're pretty much maximizing yield there. That's average across the responsive location. Okay, so the key question here is really what it basically means in terms of interpretation for soil tests. Okay, and this basically what we have here is soil test P, MELIC 3, and again we'll talk a little bit more about soil test methods, but this is specifically the MELIC 3 colorimetric, which is kind of the more common standard, I would say. However, many labs, especially commercial labs, will actually tend to use MELIC 3 ICP, which is slightly different, and the scale, if you will, it can be quite different as well. And I keep emphasizing this deal about different soil test method, and I know it can be confusing, but I think it's important to keep an eye on that, especially if you are, in programs like NRCS programs that they do. You have to keep some certain soil test values. Oftentimes, I see that the discussion may be going because somebody's looking at MELIC 3 colorimetric and someone else is using MELIC 3 ICP. In other words, we're talking about oftentimes the same thing, but that scale is different. And I'll show you some example later. But anyways, MELIC 3 colorimetric is kind of the standard, the most common critical value that was coming for corn based on the data we have right now is 22 part per million. These are just different regression models, and in average, different comes to about 22 part per million. Okay, so this is fairly close to what we have in the past for corn, so that's not a big change there, at least in the case of corn using MELIC 3. One of the main things about this project now is that we are able to look at multiple soil test methods, and this becoming more important because one thing that happens in the past with phosphorus in particular is that, we'll say, okay, if you are in a certain state, Kansas say, okay, we're going to use MELIC 3, Illinois says we're going to use BRAE 1, and they kind of develop everything based on those soil test methods. But the reality now is that you can use any lab in the country if you like. You can easily, mail your sample, and next morning it's going to be in Indiana, somewhere in some lab in Indiana, and they may use a different methods. So we need to kind of keep that in mind and be able to interpret all of these. Okay, any comments, questions so far on this?
No questions at this time, Dorivar.
Okay, Craig. Just gonna keep stopping here and make sure we cover everything. Okay, so putting things in terms of dollars, and I showed this before, and especially with higher now the prices are a little bit much better, of course. But what this basically means, essentially, whenever you're getting below that 20 part per million, slightly below that, you basically break even, and you see a pretty good response and return to investment to that phosphorus fertilizer. Now, what happens higher soil test values? And the question, obviously, this line shows that it's negative return. That's because you're not seeing a yield response that particular year. However, K-State recommendation, we do have the build and maintain recommendation where you can decide maybe to keep your soil test, in the close to about 30 part per million range, which is fine. The only difference there is that, again, you're not seeing that return to investment that particular year, but you're basically banking that phosphorus for the future. And again, a lot of guys I know when the fertilizer prices was much higher a couple of years ago, A lot of guys says, okay, I can cut back on phosphorus. It's not gonna affect my yields. I can do that, you know, for 1 year, maybe 2 years, and that I have that flexibility, okay? And that's perfectly fine. Other thing too is that especially in this part of the state, you know, we have droughts and you know, we really wanna have good fertility if we have some decent moisture some years. And so oftentimes, you know, a situation like that, we tend to keep maybe a little bit just higher just to be prepared. Hopefully we'll have the moisture like, you know, seems like we are doing this year, hopefully. Okay, once something else that we are looking with this set of data is to look at other diagnostic tools. We're looking at multiple salt test methods, but what about things like tissue tests? Okay, and you know, this is the idea with this, of course, is okay, can we use tissue analysis to tell us something about the status of phosphorus in corn in this particular case, especially when it's related to response to fertilizer. Okay, and this is where this data maybe is a little bit different to the traditional optimum range that you get from salt test labs. You know, that you get, it says, you know, your tissue analysis is in the optimum, is below optimum, or is above optimum. You get that kind of range. That data is typically developed based on survey, okay? So the salt testing labs basically running thousands of samples and say, okay, the average number tends to be around this, okay? This data that I'm showing here is really based on response to fertilizer, okay? So this is relative yield here, okay? And so what this data is telling you is that, you know, below 0.4% in the V6 corn, you start to see a penalty in yields in this particular case, okay? It's really more of a, okay, probability of yield response depending on that value of tissue concentration. Okay, now this is, you will say, well, that's not very useful, right? Because what else can you do if you find these values in phosphorus? Phosphorus needs to be applied pre-plant because it's an immobile nutrient. And yes, however, I think the key point here is that we can use both soil test and tissue testing basically in combination to, you know, get a better picture of where we are in terms of potential deficiencies and potential for yield response. Because, you know, soil test is not perfect either, right? There's some weakness there. There's some potential for errors. And combine that with tissue testing, obviously, we have a much better picture of what's happening. And so I think there's a lot of potential there, and we can. I know there's a lot more use of tissue testing in recent years, and I think hopefully, I think there's a lot more potential to keep improving that. And you know, soil testing labs tends to get in a much cheaper. Testing labs can do a better job with tissue testing and getting done quickly and better price as well. A couple of things that I like to highlight here. One of the things is that just to put a little bit in perspective, you know, the critical value here of V6 came back about 0.4%. Ear leaf at R1 in corn came back about 0.2%. Okay, so this is one thing, a good place to kind of emphasize the need to be specific about growth stages if you're using tissue testing. If you're sending tissue for analysis, make sure and specify what is the growth stage. Why? Because that concentration of nutrients tends to be different depending on the growth stage. And typically what we have most nutrients is as the crop basically develops, the concentration of nutrient is lower. You have that dilution happening basically in the plant, right? You have bigger plants, and so again, that concentration tends to be lower. Obviously, the overall content is higher because you have bigger plants, but again, you have that dilution going on in terms of concentration. So pay attention to that because sometimes I see that as well, that, you know, guys are looking at, you know, ear leaf samples and they kind of trying to interpret using values for V6, and again, they are not the same thing. So what else can we do with this kind of data? I do the set of these locations and basically put it in terms of response to fertilizer. You know, if a concentration is getting pretty low, you can see easily, you know, 50, 60, up to 100% yield increase to fertilizer if you have those deficient situations for tissue. And so again, that tissue analysis can do a decent job in terms of predicting what kind of response we may see, right? We can also, this is pretty noisy here, but also try to relate that tissue concentration basically to rates of fertilizer that maybe is needed to maximize yield. And again, deficient situation, you tend to see obviously much higher rates of fertilizer that's needed. You may be needing, again, above 60, 100 pounds, which is kind of similar to what I showed you earlier in that bar graph as well. Again, it's noisy. This is field data. Many of them in farmers' fields, but again, the trend is there. Comments, questions?
Still, nothing on questions.
Okay. Okay, so soybeans, similar type of project going on. This is across 18 sites. And I think I showed this a couple years ago. Actually, when just got it in 21. One of the things I like to emphasize with this, one of the things is that, the critical value in soybeans tends to be lower than corn, okay? It's coming back about 17 part per million. And so, first of all, that's one of the key points I think that we need to make it clear in recommendations. All the the different crops have different critical values, and we need to understand that. Right now we're saying typically we use that average of 20 part per million. When in reality, soybean can do okay with lower soil test levels. Corn maybe still around that 22 part per million. And I'll show you winter wheat here. Actually need a much higher concentration of phosphorus. One of the things, the other thing I want to show, and I know in this part of the state, pH is becoming, maybe you start to see some low pH show up from time to time. And one of the things that I really show in this case is that really mess up in terms of what happens to phosphorus response. And again, these are pretty high soil test level, but you still see that potential response to phosphorus fertilizer, but the pH is completely basically out of range there, 5.0, 4.8, that's pretty low. And so what's happening in this case? Essentially, you're seeing that essentially liming basically with phosphorus fertilizer. That's essentially what you're doing. You have a lot of aluminum here, and you're putting some of that fertilizer phosphorus. You kind of tying up some of that aluminum and allowing for more response basically in that case. And so the key message here is that in many cases we need to, especially for phosphorus, we really need to pay attention to pH. Okay, it is a nutrient that can be affected quite a bit by pH, and again, especially keeping in mind that a lot of what's happening here is that aluminum toxicity, and especially again things like soybean, which is a legume, a lot more sensitive to acidic soil. Okay, similar type of data looking at tissue concentration, a lot more noise here. But again, you do see some drop here. This is V4 soybeans. You start to see a drop in yield potential basically when you get a lower number below that critical value. But again, pretty noisy here compared to the corn. And again, we'll have to kind of look at this, is including everything, but some locations and with the drought and everything is maybe a little more noisy than what we expect. Okay, one other component that we're looking at this with this study, especially the corn, is what happened to the soybean yield the following year. Okay, and so this is a situation basically where we have many of those locations. We're putting multiple rates of phosphorus in corn, and what we did is basically came back the following year and see how soybean basically grows in some of that residual fertility. Now this is different rates of phosphorus fertilizer applied to the soybean, and this is applied right ahead of soybean. Okay, so basically spring apply broadcast before soybean. And here's the kind of the yield response you see. This average of 6 locations. You kind of maximize your soybean response there in that range of 60 to 90 pounds of P2O5 in average. How is that compared to the residual phosphorus from the previous corn? And overall, you just kind of glancing here, take a quick look, you can see that, you know, the yields tends to be slightly lower, and especially if you start to compare things like, you know, the 30 pounds of P2O5 applied ahead of corn versus 30 pounds of P2O5 applied ahead of soybean. You're seeing a much better response to that phosphorus applied ahead of the soybean, right? And so that makes sense. You know, you put in 30 pounds of P2O5 ahead of corn, there's probably not much left there by the time you harvest that corn, right? That was probably not even enough for that corn, and so obviously not much left for the following soybean. And so essentially what you see here is that 30 pounds of residual, well, residual is essentially the same as your check, basically, essentially not putting any phosphorus. Now you get into higher rates. If you're putting something like, you know, 60 or 90 pounds of P2O5 ahead of the corn, then you start to see some values getting closer there. And so there's basically some of that phosphorus left there from the corn and to the soybean, and the soybean is taking advantage of that. But for sure, with values of 90 pounds of P2O5 is enough for both crops, the corn and the soybeans. We did have one extra here, 120 pounds, and that's basically, you know, essentially the same as the 90 here. And so again, if you think about it, you get an average of 180 bushel corn, 200 bushel corn. That's removing about 60, a little bit more than 60 pounds of P2O5. And of course, you have to account for the soybean as well. So anyways, I think I like this because, you know, I like the approach that, you know, in the case of phosphorus, if you can put enough phosphorus for 2 crops and find that place to do that, you know, maybe saving some money on application costs, I think it's a good approach, especially if you're not, you know, maybe injecting that or somehow or not, you don't have any high risk of losing that phosphorus. Is a good approach. But one of the key things here is that, again, make sure you're not short. You know, again, if you're only putting 30 pounds and expecting that's going to be enough for both corn and soybean, obviously it's not the case. Comments or questions on this?
Still nothing so far.
Okay, quiet group this evening. Huh? Maybe Dina is there already. I don't know. Okay, well, okay, switching gears here in winter wheat. This is 24 locations, couple years as well. Pretty heavy on western Kansas, south central part of the state. We have some central and south central part of the state, obviously, where we have the wheat acres. So that's one thing about, you know, phosphorus in winter wheat wheat is pretty responsive to phosphorus. It typically show that visual difference, and pretty much from early in the season, and especially when you're putting with the in-furrow application with the drill, with the earth seeder, that tends to show pretty nicely. And so again, that's pictures that graduate students took, always impressed with the difference in treatments. And then when it's visual, obviously in this case showed in yield as well. Average across those locations, 24 locations, where do we see the type of response? And pretty much, you know, somewhere around 80 pounds of P2O5, you pretty much maximize the yield response that you can get in winter wheat. And again, these are all the responsive locations. This is yield removal, which is obviously just follow the yield response. But again, and all of these were basically applied broadcast. I just want to emphasize that broadcast application in the fall pre-plan. In some cases, depending if we have tillage there on time, some of these were incorporated. And in some cases were just left on the surface basically before planting, before drilling the wheat. So what do we see there in terms of critical values for winter wheat? And this again, your response here, response curve, and here's the Melick tree colorimetric that I mentioned earlier, which is kind of the default, the most common soil test methods. The data that we have shows that if we really come back, we need to have at least 25 parts per million soil test P for winter wheat. And again, this is higher than what we saw in the past, okay? So what we have in the recommendations. So to me, this is one change that should be coming next. And I was really hoping to make this change now for this publication, but we didn't quite get all the data combined yet. But for sure, this needs to be changed. And again, what's going to happen here is we basically need to improve, have a higher critical value for winter wheat when it comes to soil test phosphorus. The other thing I wanted to show here is that, we look at multiple other soil test methods, and the values are, it's different, right? I mentioned earlier MELIC 3 ICP, which is the exact same extractant solution, but we measure the phosphorus in a different instrument in the lab. And again, that value is much higher. And again, it's not that, basically what happened here is the scale is different, right? And so the interpretation obviously is different. The critical value that we're using is different because we are using basically a different soil test methods. And this is important. In the case of MELIC 3 ICP, it's actually quite common. Many commercial labs will use these because it's a quicker, faster way of doing things, and commercial labs like that, okay? Then we have Olsen, which again, for those high pH soils, more obviously as we go west. And Bray 1 is pretty similar to MELIC 3, especially if we don't have any high pH soils. Okay, so these are some of the maybe the most common ones that we'll deal with in Kansas. And again, Bray 1 is really more for acidic soil. So as long as we don't have high pH, it works pretty well. Was developed in Illinois, and again, those soils tend to be more in the 6, below 7 for sure. Okay, one that kind of got pretty popular a few years ago, but I haven't heard a lot, is the Haney test. We do have interpretation for those now for phosphorus. Is really just one different type of extractant solution based on weak organic acids. Is it better or is it worse? It really, the answer there is really depends. If you're dealing with some soils, what we found is that the Haney test in very calcareous, high pH soils doesn't work very well. Other soils works fine. And so again, many of these tests really have pros and cons. And again, that's really the issue there, and we have to see what's best for us. And again, Olsen is one that I mentioned earlier, really more for high pH Western Kansas calcareous soils work best. And here's one situation that I like to always emphasize, and just kind of focus a little bit more here on the relationship between the MELIC 3 and the Bray for high pH soils. And these are, in this case, we're looking at pH of 7.6 or higher, and those that has calcium carbonate. And again, the Bray 1 basically falls apart when you have that kind of situation. And that's the example that I wanted just to give here, that it is important what kind of soil test method we are using, especially for high pH soils. Like I say, this part of the state maybe not a big issue, but I mean, in some cases it is a big concern. Okay, something else that often comes when about phosphorus is what about placement, and how much that make a difference in terms of response. This is strip till, different placement methods, average of 17 years, corn and soybeans. And what we see here is that this is broadcast apply. This is deep band with a strip till, and this is a combination of band apply and starter, 50-50 basically, and really not a big difference. And we see this pretty consistently. We have 2 other locations, also the same number of years, very consistent, not a big difference there. Sometimes you tend to see a little bit of benefit coming from combining, putting a little bit with the starter fertilizer, and then the rest basically either broadcast or band apply if you're doing strip till. And so you do see a little bit of an advantage there, especially higher yielding environments. If you have a very low soil test, and we do have that in the recommendation. If you are in the very low soil test category, we really recommend that you split apply your phosphorus, because you tend to see a benefit in that case. But if you're in that optimum range, average yields really make no difference. And And this is an interesting discussion because, you know, we talk a lot about, especially no-till, we have stratification happening. How is that a problem? And, you know, agronomically, we haven't really seen a big, you know, difference, okay? So we basically have the flexibility there. Now we do have other considerations, you know, maybe we can have more chances of losing that phosphorus if we have pretty high concentration near, you know, the upper 1 or 2 or 1 inch or even half inch. But again, in the case of no-till, agronomic response, really no difference. And so, I mean, that's come over and over from different trials, different locations. That's pretty consistent. Okay, one thing also that we talked a little bit about this morning in the other meeting is what about, you know, if you're doing some of these trials in Manhattan or if you're doing in, you know, out in Western Kansas, obviously precipitation is pretty big difference. And I know, especially you guys, been a tough year this past year with the drought, and how is that maybe affecting placement and time of application of phosphorus? And phosphorus, again, it is an immobile nutrient, right? We know that, but at the same time, if you're putting on top, you still need to have some moisture for that to dissolve and, you know, work into the upper, you know, half inch or so of in the soil surface. We need to have that moisture for that to happen, at least for that fertilizer to dissolve. You know, if it is so dry, you know, we have those years before where even nitrogen just sitting there, right? So that obviously is not doing anything. So this is one study, you know, a few locations, 6 locations, is average of 6 locations in winter wheat, and we use triple superphosphate just because I didn't want to deal with the effect of the nitrogen here. So to really make sure is the effect of phosphorus, what we see here. This is the control here. Obviously, check show the difference there. 40 pounds of P2O5 in furrow applied with the drill. Okay, so essentially we can do that with the earth seeder. Basically, where you tend to see the best response to phosphorus. Okay, and then a little bit of lower yield here actually in the case of pre-plant broadcast, and this is broadcast apply on the surface, and then you drill that. You know, and with that drill, you kind of incorporate that a little bit, not much, but that's basically your incorporation, if you will. And then I included one treatment here, and this is something you shouldn't be doing, okay? But I was curious about this because, you know, it would be surprised. I get these questions sometimes, and it happens to all of us sometimes that, you know, you get your soil test pretty late, you already drilled you already planted the wheat. And the question is, you know, is gonna be do any good if we're going top dress some phosphorus, right? And that's basically what's the idea here. And we still see a lot. We saw a little bit of a response here, but, you know, not too different from the control. And so again, how much of the benefit you may see with some of these type of application will be directly affected by moisture. You know, if you are getting some good, decent moisture and you have some of that fertilizer dissolve and work a little bit into the surface, you can see some decent response. But if it is dry, again, this kind of response is obviously much lower, and that's where you really see the benefit of some of these placements, okay? And so obviously just a more consistent type of response what you see with this type of placement. And I think that's the message there, I guess, in this particular case. Any comments, questions?
Yeah, we got one here.
Okay.
In regards to your top dress, what's the timing he's talking? So he just expressed that, okay, we've drilled our wheat, and the situation, I run into it all the time as he does. We've drilled our wheat, all of a sudden now we got moisture. You guys didn't put phosphorus down. Is he talking about immediately after drilling, I mean, an emergence, or is he talking about this time, January, February?
The question.
Yeah, I got that.
Oh, you heard it? Okay.
Yeah. So thank you. And okay, so that's very good question. And that can make a big difference. Completely agree. In this case, what I did is just to kind of mimic what would be your typical nitrogen application time. So this was in that late February time frame. Okay. So as also a little bit maybe later. You know, if we are going now earlier, you know, January, or even, you know, December or something like that, we will actually get a much better response. I think all of these will continue to improve because it's a function of time and moisture, right? For example, let's say you did some top dress application in December and you're getting some of this snow and moisture. Obviously, this is going to be a much better situation. So I call this more of the typical nitrogen top dressing timing. Yeah, but that's an excellent question. That's going to be another key factor here. And you know what? If you're going pretty soon after after planting in the fall, right before the winter, I will argue that you may get pretty close to some of what you may see to pre-plant broadcasts. I think that could be an interesting one. Yeah, but I guess the way we designed this was much later top dress. Good question. Any other questions, comments?
I think we're good, Dorivar.
Okay. One thing that I always say, don't do these kind of things, but I do like to do it because it gives us a little bit of an idea of are we getting some benefit at all? And I think it's a valid question. We've done some things also with things like potassium and with rescue type application. And it's not ideal, but again, years where things change and we can make some changes and do some of this type of application. The other thing too is that, even if we're not using 100% of this phosphorus with this wheat crop, that's not going anywhere. It's an immobile nutrient. It's gonna be there. And so that's another advantage. So that's something that I like also about in the case of phosphorus or potassium, which we see that in eastern Kansas. Okay, so in furrow is something that obviously for wheat is tends to be much more consistent. It's just work pretty well. I like it because it's one way also that you're injecting that phosphorus. One of the questions often is how much you can put there, and thinking a little bit about the earlier study about applying enough for corn and the growing soybean. Can we do that also putting enough or maybe more with a drill with winter wheat and hopefully enough for the following crop? And the limiting factor typically is a nitrogen component, but if you're using something like 1152 or even 1846, you can put quite a bit of phosphorus before you have any issues with winter wheat. Okay, and so that's one advantage there. And so I really like that idea of being able to put with the earth seeder if we can do that, because again of the efficiency, injecting that phosphorus, and we are flexible. We can put quite a pretty high rates of phosphorus there without any concern. We've done some stuff also looking at different sources of fertilizer, 10-30-40, MAP, DAP, and if you're looking at the phosphorus component only, again, pretty similar, all the different sources, no difference there. We look at things like MESC, 40 rock, obviously you have the advantage of the sulfur, zinc if you need it, but from the phosphorus standpoint, really any of these sources are good. And again, I don't have 10-30-40 here, but obviously there have been some studies looking at that as well. They are all equivalent agronomically. And then I just want to touch on that a little bit because we often hear about, okay, what source maybe is better than others. And when it comes to the phosphorus component, they're all similar. The only reason may be that maybe you want to put more nitrogen, or in the case of maize, you want to put some sulfur. That's obviously an advantage there. Okay, so how are we doing with time? That's what I have for phosphorus. Maybe stop there a little bit, some questions, anything else, and see what you want to do. I know we're getting close to the time there.
Yeah, about 10 more minutes, just so, because it is kind of getting foggy out here, so
yeah,
get guys home safe.
Yeah, okay, so let me touch quickly here on a couple slides here on sulfur, and just and stop there again, make sure we stay on time. This is a study we done on sulfur, and this is average of 4 location, but these are really locations that are deficient. Okay, just want to emphasize that here. Again, it's really where you start to see that deficiency symptom, then basically go and put ammonium sulfate there as a side dressing in corn. And what we see there is that, especially in those deficient situations, and a lot of these tend to be a little bit more coarse texture soils, okay? Low organic matter, a little bit more on the sandier soils, those are where we usually tend to show the most. And we tend to see that typically no more than about 30 pounds is what you need. In most cases, we tend to see that, really with about 20 pounds of sulfur, we tend to capture most of the yield benefit. This for corn, we done quite a bit also for winter wheat, very similar situation. We see more consistent response in winter wheat, but now we're starting to see more and more in corn as well. So one thing that we've done in this in corn, and kind of go back to the discussion earlier about tissue analysis. These are different rates here of sulfur, okay? All the way from 0 to 30 pounds of sulfur, tissue concentration in percent, and different growth stages. V6, okay, really follow that rates of sulfur. V10 also follow that response. But if you're looking at sulfur concentration in the ear leaf, or if you're looking at grain, basically no, it's not sensitive to that fertilizer application. So in other words, early sampling, early in the season, whole plant tends to be a lot more sensitive to tissue analysis, and basically telling you whether or not we have deficiency symptom. As the season progresses, we basically, the value of that tissue analysis tends to disappear. And there are many reasons for that. Obviously, a lot of times, sulfur tends to show up early in the season and then kind of grow out of it. Now the damage probably already done there, probably going to have a yield penalty, but you don't see that visual difference anymore. So again, the severity of that deficiency tends to be much bigger early in the season. The other thing too is that, if you're looking at something like ear leaf, remember, sulfur deficiency tends to be more of an issue in the younger upper leaves. You're collecting sample of ear leaves, that's maybe not the best place for analysis of nutrients like sulfur, okay? Still one of those sampling times and plant parts that we collect pretty regularly, ear leaves, but again, not so much maybe for something like sulfur. Nitrogen to sulfur ratio, that's another number that we use pretty regularly. If we're getting higher than about a ratio of about 20, then we have a problem. We have a deficiency issue showing up there, okay? So keep that in mind. Anything above 20 is a problem, okay? We really want to keep it close to about 15 ratio of nitrogen to sulfur, okay? So that's a typical value. So if you're looking at some of your tissue analysis and you have values for nitrogen, for sulfur, you can do this ratio and kind of see where we are also. That's a good one that we tend to use. Okay, we done this across 26 sites. Again, V6 tend to be a lot more sensitive. It's multiple locations. R1, a little bit less sensitive, and then grain yield. These are kind of the locations where you tend to see some grain yield. This is across multiple locations to kind of an assessment of what kind of response we are seeing out there in corn. Okay, and typically when you see a grain yield response is in the range of that about 10 bushel. Okay, and so anyways, it's not as big as as frequent as what we see in the case of winter wheat, but it is something that is developing as well over time. One thing also that we tend to see pretty consistently is that what we can use is that, going back to kind of fertilizer recommendation, if you have your yield potential here, you can kind of estimate how much sulfur you will need as well. Okay, if you are shooting for about 150 bushel corn, that's going to be somewhere between 10 and 15 pounds of sulfur, right? More in that 200, 220 bushel yield level, closer to about 20 pounds of sulfur. So that's one way to look at this as well. Soil testing is one thing that we've done quite a bit, and we look very closely. It's not the best for sulfur, and that's a little bit of the frustrating things when it comes to sulfur. That soil test is not a really good one like it is for phosphorus or other nutrients, and that's one of the challenges. So oftentimes I tend to rely a little bit more on this kind of response. Any comments, questions there? And I think we can stop there, Craig. And if there's any other general questions about anything else, we can discuss, and just to make sure we stay on time.
Yeah, any other questions for Dorivar? He can obviously also address anything that Lucas had, so if you have anything that wasn't really addressed that Lucas presented, you can always ask Dorivar. And